Okay, welcome back. This is class number 9, and what I want to talk about this class is starting off with showing us where we left off from last week, class 8. And as you can see right away, we have our default beauty comp here for the ScreenLeft Fairy, which you folks will ultimately tweak and make your own. And then on the right side, we have the one that I showed the color integration and adjustments of the various passes to give us a better, more integrated look with the background plate. So with that being said, where we are now is we're missing a couple of things that make it feel more integrated into the shot. So let's talk about if we go here and let me just stop this down for a second. If we go to like this frame here, 1064, you'll notice that the first thing that comes to mind is the fact that there is no blurring going on with the wings. So there's motion blur on the fairy itself from the live action plate, but we don't have it here. And this is something that the CG artist did not bake in, which is actually good because this gives us control to tweak the motion blur to make it look as best as possible. And so what we're going to do is explore some of the other layer sets in that EXR sequence that we talked about last week and see how those now apply. So let's just go ahead and step into Nuke and let's see what we have here. So here, of course, are the wings. And if you remember from previously, I'd mentioned this pass here, this MV2E, which stands for motion vector. We had looked at this pass, but I didn't discuss it, and that's because I wanted to talk about it in this class here. So essentially what this is housing all the motion vector data, which will control motion blur when we actually add the right node, which is a vector blur node to it. So now that I've said that, let's also talk about another pass that we will get to later on in this class, which is the depth pass here, this one where it says CESTZ depth. And I think I'd mentioned it briefly in the class before, but this doesn't look right. And now that we can see that, what we're going to try to do is rebuild the depth pass from a camera and some geometry from the Maya file. Now, one of the things that I want to talk about is that it is not uncommon when you're working to end up with passes that are broken or something doesn't work right. That's just part of the process. And in cases like this, what this does do is it enables us to get, with Nuke, what we can do is actually do some of this work on our own without having the CG artist re-render the lighting passes for us, which do take an awfully long time. So this is actually quite beneficial for our class here. Having said that, let's just go ahead and start looking at adding a motion vector blur. So one more time, I'll go back here to the RGBA channels, and then, so here it is. Let's see, are we looking at, yes, we're looking at this transform here. So the next thing we need to do is add a vector blur. So with this, I'll just go ahead and add a vector blur, and quickly in the properties, you'll see that we have the various options. So going through here, let's start with just talking about the fact that we only want to be blurring the RGB channels, RGBA, excuse me. And that's because that's ultimately what we're comping over the fairy and ultimately the background. So if we look at this, this is where we're at, and all we want to do is blur the RGBA of the CG. Additionally, if you're blurring all the layer sets, even though it would be counterproductive, another thing to know about it is it would also take an awfully long time, because if you stop and think about the fact that Nuke has to calculate blur on each and every layer set within that EXR pipe, that's going to take a lot more time as well. Then the next thing we need to do is establish what is carrying the motion vector data. So we talked about it, and it's this MV2E layer set here. So, of course, as soon as I turn that on, you probably noticed that now we're getting some motion blur here. And this looks pretty good, but there are a few things that we can do to enhance it. Let's just start by going through the default settings as it's set currently. So with the motion vector blur, the first thing it does is it adds a multiply of 1 when in fact, realistically, this is simulating a 360-degree shutter angle, which, as you probably know, is maybe a little overkill. Another thing that we didn't actually talk about, which, or I didn't mention, which I should have mentioned, is that I've currently turned off all of our retiming nodes. And the reason why I did that is because, especially in Chronos, one of the things that we did was a fairly stylish blur as she's flying off at the end. And with that being known, that is going to cloud or make it more difficult for us to set up the motion blur correctly when we comp all of this over the background plate. So for now, I have these left turned off. With that being said, let's go back over here to the vector blur node itself and start looking at it, how it's comped over the background. So I'm just going to go and look at this output here. And so the first thing that I would like to do is just take this down to 0.5. This now, of course, will signify a 180-degree shutter angle. And when we do that, you probably noticed that the amount of blur, of course, went way down, which is good, especially if you consider the fact that we're going to be adding more motion blur with these retime nodes downstream. Okay, so then the next thing that I want to address is this offset. By default, it's set to minus 0.5, so it's essentially starting the motion blur one frame ahead or a couple of frames ahead, when in fact, realistically, what we want is the shutter to be open at the given frame, so it calculates the motion blur equidistant from the frame before and the frame after. So if we set this to 0, that accomplishes just that. So the next box that we see here is this method, which is backwards, and you'll notice there's a backwards and a forwards. And essentially what you need to know with this is that the backwards method is just almost like a proxy, and it calculates things much faster, but it looks less accurate. So for lining this stuff up, this is a great method if you want to, move through the timeline quickly and preview your motion blur. But if you want to actually see how it's going to look in the final render, let's go ahead and switch this to forward. Once we've done that, this is now much more, the calculation is a little bit more heavy, but it's more accurate. And then the last thing that I want to discuss around the motion vector blur is that you'll probably notice that there is this hard, kind of ugly edge around the wings, and that's because the alpha channels actually pre-multiplied in with the EXR or the RGB channels. So the way we can mitigate that is actually by clicking on this alpha here and just setting this to alpha. Once you do that, if you notice, now the edge of the wings actually sits in perfectly and it actually looks far more natural. So with that being said, that's the motion vector blur, and now that we've done this, let's go ahead and render this off and take a look at what it looks like once it's done. So I will come back in a few. Okay, here we are. Now we have this rendered out, and as you can see, the motion blur is sitting in much nicer, especially when you compare it against the screen left area where we haven't applied any of the motion blur. With that being said, let's go back and step into the comp. So we'll go to the comp here, and let's start rebuilding the Z-depth pass that we have here. So given this situation, this project was originally done in 2009, I believe, and unfortunately we've lost a lot of the current files and assets from it. So you'll have to bear with me in that things are not going to be exactly perfect, but we'll do the best we can here. So I'm going to bring in another EXR sequence that was just recently rendered out, and we will set this up. Essentially it's going to be very close, but there's a couple of things that are different, and we'll try to address those later on. But here we have this new EXR file, which let's go ahead and go back to the RGB. So it is different, and here is this right here is the one we were starting out with, and this is the one that I have currently. I'm going to try to have this re-rendered or built so that the reflection pass looks more like this reflection pass. But for the time being, just to teach the concepts which are necessary, we'll just go ahead and continue with this in its current form. Okay, now that we have the EXR in here, let's bring in some Alembic files, which are 3D files. And the way we're going to do that is by doing a read geo. Incidentally, Alembic is a new file format that has been adopted by Nuke 7, and so now it does have the option to import and export Alembic file sets, which is great because it does circumvent a lot of the problems that we've had in the past with bringing in OBJs or FBX files. So that being said, let me go ahead and tunnel to the actual directory. And if you get an Alembic files folder here, go ahead and drop it into the elements directory so that way this all looks correct. Let's see here. Okay, so that being said, now that we've brought this in, you can see immediately there's this intermediate dialog that asks if you want to create these various elements as separate nodes or create all in one node. In our case, what we're going to do is just hit create all in one node. And basically that if this is tied to the geo internally, then it will just come in as one separate node. In the camera and geo I have for the screen left ferry, you will end up with separate axes, but that's not to worry. It won't be a big deal. The next step that we need to do is bring in a camera. So we'll bring in a camera here, and we'll tie these together with a scene node. And then another thing we need is a scanline render node. So there we go. And now that we have these, let's go ahead and read in the camera file. So that is right here. I want to go into Elements, Alembic Files. Okay. And then it's the FG1 as well. Now that we have this, let's make sure this is FG1. Yeah, so the FG1 files are the ones that are tied to the screen right ferry. And I think that I probably mentioned that before, but never hurts to reiterate that since I find that I get confused often. Let's see here. Now we'll add a constant. What this is going to do, since the Maya camera was set up to render these EXR files at 800 by 858, we want to set the same for the scanline render node. So in the constant settings here, let's just go ahead and bring this down to 800 by 858, and then when we set that to the scanline render node, that will simulate what Maya was exporting. So then the next thing we need to do is look through the CG here, or into the 3D space. One of the things that I have experienced with the Alembic files so far, and I haven't figured out exactly why it's happening, but I have experienced crashes whenever I view in 2D view straight out of the scanline render node. So if we go here and we look at the scanline render node, if we hadn't gone through this 3D view beforehand, sometimes it'll crash. So if you run into this, my advice to you is when you reopen Nuke, just step through by looking in 3D space first. And most notably, this crash seems to happen more often than not when you adjust anything in the scene graph in the Alembic, in the geo node here in the properties. So essentially, we're going to leave everything at default. This allows us to turn on and off the various pieces of geo to be visible to the camera. So if I were to click some of these off, well, there you go. That's the crash that I was talking about. So give me a second. I will come right back. Okay, we're back. And I've set the view to the camera here so that we can see. Let me just see one more time if we can actually turn one of these elements off. Okay, so this is what I was trying to demonstrate before we crashed, that this allows us to turn on the visibility to the camera of the various parts in this scene graph here. So that's pretty helpful, and in some cases you'll find that you get extra geo that you don't necessarily want to see that's supposed to be invisible to the camera, but it'll be visible in this context, so you need to turn that off. And in the screen, left ferry, you will run into this. And so I will actually go through the steps with the screen left fairy as well, just to show it. But that's essentially what I wanted to demonstrate in there. Now that we have this, and we have the background being plugged in with the constant set to the correct resolution, now we should be able to look at this, and if we frame this up, you'll see that it looks pretty close. Now, I had mentioned earlier, let's go ahead and go to the first frame, because if you notice, this geo is, and the camera for that matter, are actually specified at this current frame range. So there's a couple of things that we can do to set this up correctly. I would say the first thing that we can do is add time offset nodes to the geo and the camera, which, by the way, is a new option in Nuke 7, where you can now add time offsets to 3D nodes, whereas previously you could not do that. It only would work with a 2D node. And the difference in the node graph, if you aren't aware of this, is that anytime you see these square corners like this, that indicates that it's a 2D node. And anytime you have these rounded elements like this, that indicates 3D. So it's a nice little tidbit to know. That being said, okay, if we go here, you'll notice that there is a slight difference from here to here, and that's because we need to make one change on this. This is unique to our current situation with cobbling together some of these elements and trying to get them to work correctly. So basically what I'm doing is taking the read file off, and what that does is it just bakes in the animation data and all the data that came in through the read file. So now it won't update if somebody were to change the camera data and resubmit, but in our case we're not doing that, so it doesn't matter. It's a moot point. But what we want to do to get this to line up correctly is turn off the animation here and set this to a horizontal aperture of 15. When we do this now, you'll notice that the camera and the rendered EXR now line up perfectly. Okay, now that these things are lined up, the next thing we need to do is just go ahead and add a time offset. So if we go here to time offset, you'll notice that this now plugs in, like I was saying earlier, to a 3D node. And the easiest way to do this, of course, is to go ahead and grab our start frame from the original geometry. And what we can do is plug this in here and then subtract our first number here so that we actually have the correct number of frames that we're actually offsetting. So now we have that, and then the easiest way to set this, we know that we want to offset this 91,673 frames, and we want to offset it in the negative direction. Whoops. So if we would just put a minus here, this should actually line up correctly when we look at the playback in the sequence here. So what I'm going to do is just copy that as well over here. So now let's just go ahead and check this out and make sure that it animates, which it does. So this is good. Now that these are lined up, the next step, of course, is to add the depth path. So currently we have we don't have a depth pass in here. We do have this one here, but we're going to recreate one from Nuke. So the nice thing about the 3D system and the scanline render node is, by default, if we look at the output of this, you'll notice over here we actually have a depth pass, and we also have motion vector pass as well, so we can sub these two back in. So let's do that. First thing we're going to do is add a shuffle copy, and we'll shuffle the depth. We'll call this depth. And then we'll just go ahead and grab, oops, excuse me, we need to actually connect this up to see that layer. So if we grab that now, we have it set to depth, and it's the Z. And then we're going to go ahead and do the same output as depth. And since we're on a roll here, let's go ahead and add another shuffle copy. And this time we will go ahead and take the motion vector pass, and that will now be for motion vector. I know we had it previously in this EXR, but I don't think it's in this EXR file set, so we're just going to go ahead and add it anyway. What we'll want to do is grab the forward UV layer and pipe that into now the forward as well, and we'll go ahead and name this forward our motion vector. Okay, perfect. And then, of course, we need to set it from the correct input. All right, now that we've done that, let's move on. One of the things that we need to do is actually pipe this into our comp now. So what I'm going to do is just take this switch node that we have here, and this is what we were using to compare our various color corrections on the layer passes, or on the lighting passes. And this time I'm just going to go ahead and take the 0 input of this switch node so we can just pipe it in and see it as it's being used. Okay, so now that we have this piped in, let's go ahead and take a look at the motion vector blur. And currently we have the wrong input, and the reason why that is because it's sourcing from this motion vector pass from the previous EXR file set. So what we'll do is go ahead and set it to the forward motion vector, and let's just go ahead and check this out real quick. And also let's just check the forward pass so we can see that it is actually there. And with that, now we should actually have the correct looking motion blur with this. So let's go ahead and verify that, which in fact we do. So there we go. Let's now that we've got this in place, now let's actually switch this off and add a Z defocus node. So what I'm going to do is just branch this. So Z defocus. Okay. And a couple of things about this. One of the things you'll notice is there's a new input on the Z defocus. This is new as of Nuke 7. Basically, this filter input allows you to create an image for controlling the bokeh of the actual blur. And that's something I'm not going to get into, but if we were to do that, you would actually set this up here where it says filter type, and you would actually set it to image. So that's what that new input is all about. But while we're moving with this, let's go ahead and set this up. Currently, you can see that it's completely blurred out, and that's because we haven't actually set up the focal plane and we haven't set where the focus point is. Another new option with the Z defocus node as opposed to the Z blur node from Nuke 6 is that you now have this little focal point which you can just put onto the geometry. It's almost like the ST map, where it'll just map out where it is on the geo from the Z depth map and establish where you want something to be in focus. So now that we've done that, let's go ahead and talk a little bit about what we have here. So this output here allows you to go into the focal plane setup that you had previously in the previous node. And so essentially we can see right away that this is what we want. Right around this area is where we want it to be in focus. And then also the math is far equals 0, and that, by the way, is what Nuke is. That is if you were using Nuke to create your Z depth. So in Maya, it's going to be the inverse. So you would probably set it to far equals -0. But for our purposes, this is going to work just fine. And let's also explore a little bit of this in case you haven't worked with this focal plane setup. If you want to iris down and go for a greater depth of field, you could actually expand this, and then you'll see this green here, which means that everything in the green is perfectly in focus. But for our purposes, we know that we do not want to do that. We want to keep our depth of field as shallow as possible because of the nature of these fairies being small. We want it to feel small. So let's see, moving along here, let's step back out to our result and see what we have. The first thing that I'm seeing is that we're getting this weird fringing going on, and I suspect that is the result of the scanline render node not actually producing the right Z depth out of it. So if we go ahead and set our anti-aliasing to high, I think we should probably be looking a little bit better. Yes, we do. Okay, very good. And now let's one other thing we need to do is check how this is going to relate to the live action plate. So let's go ahead and go to the live action plate. And if I'm not mistaken, she takes off right around here. So this is probably a good frame for us to actually establish that focal length. So one more time, let's go back to the Z to focus and make sure that this is set up correctly. Okay. And another thing that I think we'll probably do is actually normalize the Z depth pass, which once again, looking at this, it doesn't change too much. And I think what we might want to do is just to give this a tighter depth of field, a feel to it. We might actually normalize this with a grade node. But before we do that, let's just go ahead and make sure that this is set correctly, which I think it is. Let's go back here. And let's actually view whole frame increment for a second. Yeah, this looks okay. Let's go ahead and actually add a grade node here to try and make our defocus a little more intense or pronounced rather. So I'm just going to add a grade node here. So essentially what we're going to do is clamp our Z depth pass. So it'll be, we're going to do the Z depth here, and let's go ahead and step through. So we'll set this to buffer 1 and this to 2 so we can compare the two. And let's look at the Z depth. So what we can do is actually we can start to see what's happening in here by taking the gamma down. This is basically going to allow us to see a little bit of gradation. So yeah, this really doesn't change too much. This is pretty flat, but this value range is all between the values of 0 and 1. So we know that our black point is always going to be 0. So the easiest way to set this up is to actually take our white point down, and then we should actually have, and actually let's go ahead and set this up. So we should be able to get a change in the value here. So what I can do is something like this. Take that off, and now, and maybe actually we could take our black point up a little bit. This will help normalize it a little bit more, because it seems like our Z depth, and actually this is probably not a good frame, to be honest, because there isn't much depth here in the first place. This frame here is probably much better. So now that we have this, let's see if this changes any. Okay, now we're starting to see some depth in here, and this is exactly what I wanted. Let's just go ahead and look at the differences on the Z depth. So on the Z blur, Z defocus here. And with that, now we're actually seeing a really tight depth of field, and now this feels much more miniaturized by doing that. And that's exactly what I was trying to accomplish. So with that in mind, now I believe when the fairy flies out, and let's go back here to the fairy herself, and let's see. So right around here, she's actually getting closer to camera. So theoretically, the depth of field should be a little shallower, although this is pretty wide anyway. But let's see what this looks like on this frame here. So it should hopefully be out of focus, which it is, and that's exactly correct. Okay, so with that being said, I think that this what we'll do now is we'll go ahead and put this in the chain here. So probably easiest to do it this way. So now we have our motion blur after the fact, and when we look at this comped over, let's see how this looks. Now it's got a few things to calculate, so it may take a second. And let's go ahead and go back to where we think she's in the frame. There we go. And now we have some defocus and some motion blur going on, which feels pretty good. And now I know that, like I said previously, the EXR file here is different, and until I get this sorted out to get the proper EXR, at least now you can see how this is, see the process for how you would actually add these various channels in by virtue of having geometry and a camera. Lastly, before I close, what I'd like to do is just quickly step through with this screen right ferry, or excuse me, screen left ferry. And this here is the EXR, and of course we have the same issue with this pass as well, where the depth wasn't looking quite right. So, and you know, some of the other issues that we had established previously. So what we'll do is bring in camera and geo. So I'm going to pause down for 1 second and just bring in the cameras and geo and show you how I set it up and some of the slight differences therein. The first thing actually that I wanted to establish was if we go here and bring in the FG2 wings, it's this one here, you'll notice that the intermediate dialog box is slightly different here. So even if you create all in one node, you'll end up with this these two axes as well, but that shouldn't be a problem. So we'll just go ahead and create a scene node like so and tie those together. And then also let's go ahead and add the camera. So one more time, we'll go through this process here of adding the camera file. So here we are, and let's see, it's FG2 cam. I believe that's the correct one. And let's tie this into the scene node and once again add a scanline render. And and then previously what we were doing is adding a constant to set that to 800 by 858, which is what we were establishing what Maya was rendering out at. Now, one thing to note is that in this particular case, this is, for some reason, this has been resized to 1200 by 858. So if you look at this, we also need to add the time offsets, which, come to think of it, since we've already created those up here, we can just go ahead and grab this and apply these to both the camera and the geo here as well. So once there and once here. And I'm wondering if we need to, we need to add it to the axes as well. Let me think about this. Is there an easier way? There might be if I were to put it under the scene node, but then, yeah, no, we can do it that way. So what we'll do is we'll take this out here, just plug this into the scene node, and then just set that. So now everything should line up correctly, with the exception of the actual resolution, which I'll get to here. So it still doesn't look right. Oh, no, that's right. What I was talking about earlier was that I ran into this when I was setting this up, where we have this group here. So hopefully, let's go ahead and go into our 3D view. What we want to do is remove this the body here. So if we click this off and we're just left with the wings, then this should actually be correct. So hopefully it won't crash. I'm just gonna go here. Okay, well, one more time. I will return in just a second. Okay, I'm back, and I am going to try to turn this off again and close this, maybe save it. And now, okay, so come back here. Now if we step through, I think that we should be okay. And now this is lining up correctly. So now that we have this, one of the things I'm going to do is just put this over the background, or over the EXR rather. And as I was mentioning, there is one other step here to get this to line up correctly. So if we just add a reformat now from this point forward, what this will do is actually expand the bounding box so that it's 1200 and center this, which will then of course line this up correctly. So with that being said, I'm going to add the reformat. Did it not take? Let's try this one more time. Reformat. Okay. And what we'll do is we'll set this now to 1200 by 858, which is what the resolution is. And then instead of doing any resizing, we'll just set it to none. So once you do that, then this lines up. And actually, if I fade this off, you can see that this is lining up correctly. So those are the steps necessary to get you to this point. So I'll go ahead and clear this out and let you do this on your own. And by all means, have fun with this. I think it's pretty cool that we have an opportunity to try to add these various passes, because this is great, given the fact that this is something that does happen frequently in production. So have fun with it, and in the meantime, I'm going to try to sort out this EXR file and try to get something workable for the next class. So thank you, and hit me up on the forums.